Let's start with the lookup function. It's one of the older lookup functions in Excel and is often overlooked because of newer alternatives. But it's still useful and can perform both vector and array lookups. The lookup function automatically adjusts its behavior based on the arrangement of the data. If the data is organized more horizontally, with more columns than rows, it will search the first row for the lookup value and return the corresponding value from the second row. This flexibility allows for seamless lookups in both vertical and horizontal arrangements, making the lookup function versatile for various data structures. The lookup function can be used in two ways: vector form and array form. In the array form, lookup searches for a specified value in the first row or column of an array and then returns the corresponding value from the last row or column of that same array. This form is particularly useful when the values you want to match are located in the first row or column of the array. As shown on the screen, I've used the lookup function, which returns Clara Hughes' score from the last column of the range. Now let's try to find another student, Brian Gomez, using the same formula. However, it returns NA error, even though his name and score are in row 5. Strange, right? Let's check Bob Smith next, and we see it also returns NA error. In the array form of the lookup function, it searches for the lookup value in the first column. For this to work correctly, the values in that column must be sorted in ascending order. Let's sort our data based on the first column to get accurate results. On the Home tab, click Sort and Filter in the Editing group and select Custom Sort. If you haven't selected the entire dataset, Excel will prompt you to expand the range. In the dialog box that appears, choose the first column in the Sort By dropdown and select A to Z in the Order dropdown menu. Click OK. Now, after sorting the data by the first column, the lookup function works perfectly, returning the correct corresponding values. Remember, this function is case-insensitive, so uppercase and lowercase text are treated as equivalent. Next, let's explore the vector form of the lookup function. This form allows you to search within a single row or column for a specific value. It is ideal when you want to define the exact range containing the values you want to match. The lookup function's vector syntax consists of 3 parameters. The first parameter is the value you want to find. The second parameter is the range of cells where you want to search for the lookup value. This must be a single row or column. The third parameter is the range from which you want to retrieve the corresponding value. The third parameter is optional. If you omit it, the lookup function will return the value from the second parameter. In contrast to the array form, the vector form allows you to precisely define both the search area and the source of the data you want to retrieve. In the example displayed on the screen, I search for the score of 86 to retrieve the name of the student with that score. However, you can see that Clara Hughes has a score of 86, yet the lookup function returned a different name. As with the array form, it's essential to sort the data according to the range specified in the second parameter of the lookup function. Since we haven't sorted the data in ascending order, the function failed to find the correct result. Let's sort the data. Select the entire dataset, click the Sort and Filter button on the Home tab, and choose Custom Sort. In the Sort dialog box, select the column you use for the lookup vector. In this case, the second column named Score. Then choose Smallest to Largest in the Order dropdown. Click OK to apply the sorting. Now you'll notice that the lookup function returns accurate results. The usage of the lookup function can be a bit tricky. When the lookup function cannot find an exact match for the lookup value, it will return the largest value in the lookup vector or array that is less than the specified lookup value. This means that the function is designed to find approximate matches. If the lookup value is smaller than the smallest value in the lookup vector or array, the lookup function will return NA error. This indicates that there is no valid match for the provided lookup value. Let's try searching for a student with a score of 50. You'll notice that while there is no exact match for 50, there is a score of 49, which is lower. As a result, the lookup function will return the name of the student with a score of 49. Similarly, when I search for a score of 57, which also doesn't exist in the list, the lookup function again identified the next lowest score, which is still 49. Consequently, it returns the name of the student with a score of 49 instead of 57. This behavior is referred to as an approximate return. In summary, it's important to understand how the lookup function operates. It will always return an approximate match if the lookup value doesn't exist, or it will return NA error if the lookup value is less than the smallest value in the lookup array or vector. The approximate behavior of the lookup function can be particularly useful for generating student grades based on their scores. You can create a grading scale where each grade corresponds to a range of scores. Let's set up a table that lists the minimum score for each grade in one column and the corresponding grade in the next column. When you use the lookup function to find a student's grade based on their score, it searches for the highest minimum score that is less than or equal to the student's score. This allows for automatic grade assignment without needing to create complex conditional statements. For example, if a student scores 85, the function searches for the value less than or equal to 85, which is 80. As a result, it returns a grade of B. Let's edit the formula by adding $signs to the references pointing to the lookup table we just created. This will prevent the row numbers from automatically increasing when we copy the formula. Once that's done, double-click the fill handle to copy the formula down to the end of the data to generate grade for each student. In all our previous examples, we used the lookup function to find values in a vertical column-wise manner. However, if we need to search for values in a range that spans across rows, the lookup function automatically adjusts its behavior when the data is square or wider than it is tall, more columns than rows. Let's update our lookup table. Delete the previous one and create a new table with more columns, as shown on the screen. Now, when you use the lookup formula to search within this new table, it will automatically reference the first row for the lookup values and the second row for the results. The lookup function has several drawbacks that you should be aware of. 1. Sorting requirement. The data must be sorted in ascending order for lookup to work correctly. If the data isn't sorted, the function may return incorrect results or errors. 2. Approximate matches only. Lookup defaults to approximate matches, which can lead to unintended results if exact matches are required. This behavior may be confusing in certain situations. 3. No case sensitivity. Lookup is case insensitive, meaning it does not differentiate between uppercase and lowercase letters. This can lead to issues when exact text matching is needed. 4. Performance on large data sets. For very large data sets, lookup can be less efficient compared to other lookup functions like VLOOKUP or XLOOKUP, especially when searching for exact matches. 5. Obsolete in some contexts. With the introduction of more powerful functions like XLOOKUP and filter in newer versions of Excel, lookup may become less relevant for many use cases. These drawbacks suggest that while lookup can be useful, it's essential to consider the context and whether other functions may better meet your needs. Thanks for watching. If you enjoyed this video, please give it a thumbs up, share it with your friends, and subscribe for more updates.